For the rest of you, are we psyched about programming a little robot?
Yes.
Okay. So what you're all going to do is you're going to go to Google again. You can probably close down your circuit wizard, circuit designs. So I'm going to, this is already saved, by the way. If you ever want to come back to this, this is automatically saved. So you can always just come back. We're going to go to Google. We're going to go to Roboton. It's an interesting word, .io. Okay. You're going to enter roboton.io. And you're going to head to virtual robot competitions. Okay. Then you're probably going to want to create an account or sign in. And I'll give you some time to do that while I show you my latest creation that kind of works, but I haven't really had time.
How good does it work?
I haven't had time to fine tune this. So this is my current model.
It's asking us to pick a programming language. So
code.
Yeah, so you're going to choose
code blocks.
You're going to choose blocks.
Okay.
Okay. So this is what I've got so far, Ali. And Ali, I'd love you to have a go at this. Rob as well. Okay, so guys, on your dashboard, once you're there, you're going to click on a new maze solver. Okay. And let me know with a hands up once you've managed to create an account and you can click on new maze solver. You're going to click on blocks. So when you open it up here, it's going to ask you, you're going to click on code blocks, the one on the right. Okay. And then please don't press anything just yet. Just give me a hands up when you've got to this stage here. We're going to be working with Roboton.io. For those of you that are joining us for the first time online, you're going to have to head to Roboton.io, create an account, head to Dashboard, and then choose New Maze Solver, and programming language is code blocks. Okay, that was just for anyone joining us online if you're watching the recording of this. Right, so back to our presentation, lovely made. Basically, here we're going to make a virtual maze bot, and we're going to do it with 3 languages. We're going to focus on blocks because I can't be bothered to teach you guys in an entirely new language today. The first thing we need to consider when we consider a project like this is what are we controlling and what are our inputs. Okay, so what are our inputs and what are our outputs? What do we have to work with? So our input, we have 5 distance sensors. So here our little robot, and I'll show you this on here. Here you can also choose to pan around. If you use your right, you can actually pan. Here you can view, and you can obviously scroll in. Okay, so this is your little robot. Everyone say hi to your little robot, and give him a name. I've decided to name mine Rupert the robot. And on Rupert, you can see that we have 5 distance sensors, which are shown by these lasers pointing out. Okay. So everyone can see that we have the 5 distance sensors, and he's got 4 little wheels. Oh, where's my presentation gone? Okay, so we've got these 5 sensors going out: front, left, 45, and right 45. Very conveniently named. We then have our outputs, 2 wheels. We can change our left speed and our right speed. Okay, everyone happy with that so far? Hands up. Just want to see a flurry of yellow. Lovely. Okay, so how to use blocks. What do the blocks do? Basically, blocks are easy drag and drop bits of code. We're only going to look at these because we need to look at the kind of algorithm, and it would be a lot to go through the actual syntax of the languages. So we're going to stay within our control function. Okay, our control function is, I should really stop doing that. Our control function is this over here. Okay, you can all drag your little block about. Okay, and here our control draws in left 45, front 45, right, and then the other stuff you don't need to worry about. Okay, so we're going to draw it in, and this is going to be like our loop statement earlier on. Okay, so what you can all do is, you can see here we've got a block that we can drag out, and we can separate these 2 here, and it makes a little clicking sound as well if you haven't got your microphone muted. and you can set your left speed and your right speed. Okay, so if we take this block here, we can set our left speed to 10, okay, and our right speed to 10, okay. Then when we click practice, Rupert over here is going to race off at a speed of 10, okay. The only problem is there's no pause on this game, so when Rupert reaches the end, what's Rupert going to do? He's going to hit the wall and he's going to want to keep going. Okay, Rupert's not all that bright. We can choose to run that again faster, so we're going to set the speeds to 20 and 20, and we're going to see him race off this time at 20. If we choose to send our wheels in opposite directions, so sending our left speed to 20 and our right speed to -20, what's it going to do?
It's going to turn.
It's going to turn. So when we do that, he's going to spin like crazy on the spot.
Going to spin, okay.
Okay. Right. So it's up to you guys to basically program everything within here using these blocks. Okay. So we've got blocks here. We've got logic. So we've got our if statements that we're all too familiar with now. So we've got our if do something, right? We've got our if do something otherwise or else here. We've then got if do this, execute this bit of code. Otherwise, if this statement, execute this bit of code. Otherwise, execute this. We've got an operand checker here, so we can choose to check two variables and see whether they're greater than, smaller than, or equal to, just like we were doing before. We've got some other stuff that you can use as well. You've got loops. Let's not use loops because that's just confusing. You've got math, so you've got numbers that we can drag in, just like here. We've dragged in a little numbers. We've got addition or subtraction. We've got is equal to, random, rounding up, all kinds of things. Text, we can choose to drag in a little text block, and then we can write Rob smells in there. Okay, and that's going to tell us that Rob smells all the time, and we're just going to keep that at the top of the page because that's a little important note to us. Okay, you can have lists and kind of things like that, arrays. You can have variables. Okay, so these variables are like left speed and right speed are variables. They are just things we have assigned a value to. Feel free, guys, to ask questions at any point, please. It's rather useful if you do, because then I can make sure we're all at the right point. Okay. So here we're going to set right speed. So we can choose to set right speed to, and we can click and add on our little number block. And then we can choose to set our speed to 3,900 and just whatever. We can set it to whatever we want. Okay. So there we have our variables, and you've got them for your front sensor, your left sensor, your left 45, your left speed. So that's the left motor, your right 45, and your right speed. Okay. Don't worry about encoders just yet. So we can set the values to something, or we can change them by a value. Okay. And then you've got functions, but we're not going to mess with those in this tutorial. Okay, so first thing we need to do is we need to get familiar with code blocks, right? So let's go back to my gorgeous presentation. Here, the loop, the control loop approximately runs every 16 milliseconds, takes in all our inputs and sends out our outputs. Okay, it sends out our outputs. We can see here, it draws in all of these inputs. And at the end, when it reaches the bottom, it returns our left speed and our right speed to Rupert and tells Rupert what the left speed and right speed should be. Okay, so all of our inputs are outputs, and we do a bunch of code in the middle. Everyone happy with this? Hands up. Right, so first thing we're all going to do is we're going to stop running it on the maze, and we're going to choose straight. So you're going to click small, you're going to click straight, and we're going to see that there is a straight path now, okay? So now we're on this line. Okay, and once I actually manage to zoom out, because my scroll was pretty screwed, we're going to see Rupert still spinning around on the spot like a nutcase. Okay, fantastic. Right, so what we want to do now is start getting familiar with the code. So first, let's get Rupert to go forwards, but not hit the wall. Okay, the wall directly in front of him. Okay, so the first thing that I'm going to promote you guys do is think of the idea and come up with what we call pseudocode. Martine, you can remove your hand. Pseudocode is basically how we write out our code in a very abstract format. Okay, so we want to say the idea is if he faces a wall, we're going to stop. What does that mean? If our front sensor is less than 5 units of distance, I'm just going to call it 5. set our motor speeds to 0. Okay, so what does this look like? We get our if statement and we say if, and we drag this here, and you can see it drags in nicely. If, let's say, then we're going to drag in this one from logic as well. I'm going to drag in this one, and we're going to drag in our variables. If our front sensor is less than 5, can anyone guess what we're going to do now?
Stop.
Okay, and how are we going to stop it?
Oh, speed 0.
Speed 0, right. So we're going to drag these two. We're going to set them in here. And we're going to set them to 0. Okay. So this is say if our front sensor is less than 5, we're going to set both of our speeds to 0. Okay. But the problem is when we run this, we haven't actually initialized, we haven't started the motors spinning in any specific type of speed. Okay. So what we're going to do is we're going to take this one. Once again, because street smarts, we're going to copy and paste these two up here. And these are what we're going to call global variables. Okay, we're going to start off initializing left speed and right speed to 10 and 10. This is going to actually get him to go off, set off at the right speed. Okay, so is everyone happy with this? Everyone managed to copy this? Hands up. So here we have our code, and what we're going to do is we're going to click practice, and we're going to watch Rupert. You can all name your own one. I don't want you guys stealing Rupert from me. Okay, Rupert's going to go down the track. He's going to fire off down the line, racing out of the gates. You can set your initial speeds higher as well if you want. Just follow him all the way down the track. Oh my God, Rupert, speed up. We don't have all day. All right. Moment of truth. Can also everyone see that we're going such down a long track? He's no longer in the center. Can everyone see that? He's now drifted a little bit to the right. Anyway, we're coming up to the moment of truth. Yay! All right, well done. Okay, so that's because the creators of this software, who we know, have added a little bit of noise, a little bit of inaccuracy to the motors. So actually, Rupert will not always stay in the middle. He will sometimes drift a little bit left and right. And that's just realistic. That's just what you'd get on actual motors. Anyway, that's all well and good. We've got Rupert across to the other end without bashing his face in. So let's focus on another task. That was fairly easy. Let's get Rupert to stay in the middle. Like I said, Rupert likes to drift across the line. Let's try and keep him roughly in the middle so he doesn't go scraping into the corners. Okay. So for this one, what's the idea? You can all lower your hands, by the way. Oh, Umar, you've got a problem?
Yeah, my robot's not moving. It's staying.
Okay, so let's go back to this. Have you set his initial speeds here?
Yes, I have.
And have you said if front is less than 5, not greater than?
Yes, I have.
Okay, is this copied exactly like this? If so, please send a screenshot to the group and Rob Smells will check it.
Rob Smells is going to start charging you for editing soon.
Wait, Ben, my robot, it doesn't go straight. It just bangs into the wall on the left.
It doesn't go straight. Okay, have you made sure that you set left speed here? Because if you copied it, you might not need it. You might need to change left speed to right speed for the other one.
I had both.
There we go. Umar, have you got yours going yet?
Yeah, but for some reason it keeps rushing into the left again.
Okay, again, same thing as I think Fardin. Make sure that you've got one set up here to left speed and one set to right speed. Clicking on this brings down a drop-down menu.
Yeah, I put it. Yeah.
Okay. Has everyone got theirs to stop at the other end of the line? Hands up. Okay, so what we're going to do now is we're going to say if Rupert is too close to one side, get away from that side. Okay. So if he's too far away, we're going to push away slightly. What we're going to do is instead of getting Rupert to spin around like immediately on the spot and keep going. We're going to just get him to speed up one side of his wheels so he kind of just climbs away. Okay, so what we're going to say, on top of our initial stop, we still don't want him smashing into the wall. If our front sensor is less than 5, set the motor speeds to 0. Else if, so this is another if statement, else if the left sensor is less than 5, so our sensor here, if this one on the left is less than 5, increase the left motor speed, right? And decrease the right motor speed. So that means that he's going to drift along back into the middle of the line. Okay? Everyone happy with that idea, that premise? Cool.
Yeah.
Then again, we're going to make another else if statement. So if the left sensor is fine, check the right sensor. If the right sensor is less than 5, increase the right motor speed and decrease the left motor speed. And then he's going to vary across and veer into the middle again. Otherwise, if both of the sensors are fine, if all the sensors are fine, keep the motors at the same speed as each other, and hopefully he'll head down a lovely straight path. Okay? And this is what we call a bang-bang controller, or a very, very trivial system, where basically he's going to kind of bang from side to side saying, oh, I'm too close here, I'm going to go over here, I'm too close here, I'm going to go over here, and he's going to kind of zigzag up the path. Okay? So we now need to take this pseudocode, this written text. Also, Ali, Fardin, and Martin, you can move your hands. We're going to take this pseudocode and we're going to use our logic. So we're going to come here and we're going to take our biggest statement now. We're going to take the one that says if, do, else if, do, else. Okay? And we're going to say if, we're going to drag our front, set our speeds to 0. Okay, so this is the same as before. We're just getting rid of this smaller thing. And now we're going to say the first one we're going to check is our left sensor. So we're going to be street smart again, copy and paste, and we're going to choose our left sensor is less than 5. And annoyingly, the people that created this didn't do a double copy and paste, so you have to copy and paste each thing separately. We're going to then, if we're too close to the left, we're going to speed up our left side. From 10, we're going to speed it up to 12, not too much. And we're going to slow down our right side, probably actually just leave it to 10. Okay. So we're going to set our speeds like this. Now, we want another 2 if statements here. Okay. Sorry, we want another 1 if statement. So we're going to click on this little icon up here. And we can drag in another else if statement there. Okay. Right, so we're going to add in another statement, and we can see that that's dropped in. Click on the gear, and it will stop. Street smarts, copy and paste. If our right sensor now is less than 5, what are we going to do, people?
Do you increase the right speed?
We're going to increase the right speed. So we're going to lower this one down to 10, and we're going to increase this one up to 12. Okay. Is everyone following along? Everyone happy with this so far, what we're doing?
How do you get the extra else if?
So you need to click on this little gear and then drag in another else if here.
Oh, okay.
Yeah. And then to get rid of it, click on the gear again. Okay. What are we going to put in this else statement? Does anyone remember?
Speed the same.
We're going to keep the speeds the same. Okay. So again, copy and paste. And then this time, we're going to keep both motors running at 10. Okay. Everyone happy with this? Everyone got this copied down? Hands up if you have. Also, Rob, did you see that I've called you nice and lovely up here?
I know.
Oh, so you fear me now then?
You have leverage. Everyone happy with this so far? It's going to start ramping up in a bit of complexity. I know, but trust me, it gets wild. One thing that might be worth noting is obviously we've set his parameters to 5 and 5. So we've said if he's close to the left side or right side by 5, we can vary it. But we set that as an arbitrary value. We can actually say less than 6 or more than 6, and you can try that out. One thing that might be worth doing is when you practice, pan all the way back to the beginning, find your robot, pick him up, grab him while you're running the practice, and put him too close to the side and see what happens. See him veer away and see him now do the zigzag, okay? So you can pick him up, pull him all the way back, poor little bastard. And you can make him zigzag all the way, okay?
I threw him off the map.
You threw him off? Don't do that. Don't do that. Reset the practice. So what you can do here is you can also then change the values here. So we can change if left is greater than 6 and 6. And I'm going to get him to go 15 speed the other way and 15. So you can just get weird with some of these numbers. And so now when I pick him up and he gets too close to the wall, he's now a little bit more sensitive to any changes. Okay, so here, if he's a little bit too far away from the wall, do we get the idea? We get the premise. You can fiddle around with these numbers. Yeah, hands up if you understand what I'm talking about or if I'm just chatting baloney. Yes, Ali, love it. Okay, guys. So you can fiddle around with some of these numbers, but most of that isn't important right now. It just makes him less or more sensitive to things. Okay. Anyway, so back to our presentation. Has anyone not managed that? Anyone had problems with Rupert or their robot so far? Okay, I'm going to take silence as a good thing. Okay, so we're now going to get Rupert to turn around. Okay, because it's all fun and games, him getting to the end, but it'd be nice if he actually picked up. So now, instead of getting our front sensor, when we detect the wall in front of us, when we detect the wall, instead of getting our front sensor to cut off our motors, we're going to get it to spin him around on the spot and get him to carry on going. Okay? So all we're going to do is set our right motor speed to 10 and our left motor speed to -10. Okay? So can everyone have a crack at doing this and running it before I show you, please? Right, so guys, that's great. We've got him doing this. Now I want you to change your thing from a straight to a small maze. Okay, and now look at him go, shooting up and down the small maze. And as you can see, he's just kind of wiggling his way through the world. Okay, so what we now have is a kind of solution. However, this is not a great solution. Okay, it's not an ideal one for an end. If you're trying to solve the maze this way, you're going to have a lot of trouble. Also, can everyone lower their hands? Thank you. So this isn't a great scenario. Let me pose to you a situation, a scenario, if you will, if we were to carry on. The next step for us would probably be to say, if you reach the end, your right sensor, let's give it this scenario, your right sensor is going to suddenly shoot off with a really high value. Okay, so we can say if our, let's not do that. If our right value goes really high, we want you to turn on the spot, like so, and then he's going to carry on going. Okay, now the problem is that what we've written is a loop. Okay, this whole thing loops over and over and over and over and over again really, really, really fast. Okay, so if we have this scenario, we see a big gap on our right. We tell Rupert when the right sensor is big to turn towards the right. Okay, he's now going to come up here. He sees the lovely right gap, and he's going to start turning. However, while he is turning, that loop is still checking all the sensors for the front, the sides over here, and checking whether he's in the center, whether he's centered properly and everything that we've got going on. So he's going to keep turning. Fortunately, the right signal is still very long until we get to about here. Okay, now this right signal is actually, in fact, rather short. And so Rupert's going to go, there's no gap on the right in the loop, so I'm going to shoot forward. Okay, he's then probably going to detect the wall in front of him up here, and he's going to go, there's an object in front of me. Rupert's not very smart. Rupert's then going to go, I'm going to turn around. Rupert's going to carry on turning around. We might have just got away with it, fortunately. However, now Rupert's probably detecting one of two things. One, this side here is really short. I need to push myself away from this wall. Good. Also, this side here is really, really long. That means there's a gap. I'm going to keep turning. There's still a gap. I'm going to keep turning. Do we all see the problem? Rupert is now detecting the gap he came from. And so now Rupert is going to keep turning. He's going to keep thinking that there's an empty space over here. And he's going to get stuck in an endless loop, following himself around his own tail. Okay? Does everyone see the issue with the way we're doing it?
Yes.
Okay, so essentially, at some point, the sensor will be low again, blah, blah, blah. Basically, he is checking his sensors while he's trying to perform an action, okay? And that's not a very, very clever way to work. So what we need to do is introduce a state machine. Okay, has anyone ever heard of a state machine?
No.
Okay.
Yes.
Oh, great music in the background there. Okay, a state machine basically reminds Rupert what he was doing. It tells him, Rupert, you're actually in a turning state. Okay, so how about you don't look at your sensors and you focus on turning? Rupert's going to go, great, that's a fantastic idea. I'm going to carry on doing that. So basically, if you're performing an action, remember what action you're doing and ignore certain aspects. That is essentially what a state machine does. Okay, so we're going to start. We're going to tell Rupert to go forward. Okay, that's how we're going to initialize things. If he's going forward, if the state is going forward, this is our state. It's a variable that we're going to make. If our state is going forward, we are going to then know that we are clear ahead. We're going to check. We're going to start checking for things. Okay, do we need to turn? Do we need to check for incoming walls? This is all stuff we've done, remember? We've written the code already for incoming walls, and we've written the code for making sure that we keep things centered. Okay, this one, checking for gaps, is essentially have one of the left or right sensors suddenly gone really high. And when I say gaps, I mean a point like this. Okay, that would be a point where his right sensor, such as now, is going to go really high. Okay, so that's a gap. If he finds a gap or if there's an incoming wall, he probably needs to change his state to a turn state. Okay, if the state is now a turn, we're going to loop through this. Remember, we're looping through our state matrix the whole time. But this time our state is turning. So we're going to go down here. We're going to say our state is turning. Are we still turning? Okay, is Rupert still turning? If he is turning, he carries on. He carries on turning and the state is still in the turning state. If he has reached the end of his turn, if he said, right, I've completed that, I can start looking at my sensors again, we're going to go back into our state of straight, okay? And then he's going to go back here and he's going to check all his sensors and he's running through his sensors again. Okay, does everyone see the value in this and why we do it? Right, so how do we actually know? Because I've said, you know, all's well and good saying, right, are we still turning? But how are we actually going to make sure that we've turned 90 degrees? Because as you can imagine, Rupert can just turn. And we'll be like, okay, turn, but for what measure? Okay, a clever way of doing this would be to make sure that Rupert turns all the way until both our 45-degree angle sensors are at a perfect measurement and we can do some special functions. We're not going to do anything clever. We're going to just time it. We're just going to say Rupert usually turns 90 degrees in XY amount of time. Okay. And we're going to time it because our loop takes 16 milliseconds, if you remember, to do a full loop, right? So we're going to involve a counter. Okay. A counter is basically going to when we do that. Oh yeah, every time we're in a loop, we're going to decrease our counter until 1 until we've completed the turn. Okay, so if we're turning, we're going to run through the loop, decrease our counter once, run through it 2, decrease our counter twice, keep going through the loop until he's finished turning. He's done an approximate turn, and then once our counter is 0, we're going to say, cool, we've done the turn. We're going to go back to our state of forward. Okay. So what this looks like is we initialize a new variable called counter, okay? And if our state is going forward, we go through all our checks. If we need to change our state to a turning state, if he's detected a reason to turn, we're going to change our state to turn as before, and we're going to reset the turn counter. Okay, we're going to change our counter to on. If we are turning, if the turning counter is here, we've got our counter on. Are we still turning? This question is now answered by, is the turn counter more than 0? Okay. If it is, we're going to carry on turning Rupert, turn. And we're going to decrement our counter by 1 value. Okay. Then we're going to check, is the state turning again? Has he finished that turn? Who knows? If he has, we're going to set our state to straight and we carry on checking our sensors. Is everyone okay with what we're about to try and do? Okay. And then finally, it's a useful kind of note. Thank you, Ali. It's a useful note to consider your scenarios. Okay. So here we can reach a complete dead end in our maze, and therefore we need to do a full 180 turnaround. Okay. In these two cases, we might have reached a dead end, but the right sensor is really, really high. Therefore, we need to do a right turn. We might also reach a point where we're just halfway through and we've reached a gap and we need to also turn. The same thing for our left side as well. Okay, so what is this going to look like? Right. So firstly, guys, we're going to set our, we're going to create some new variables. Okay, we're going to create a variable called turn counter. I'm going to call it turn counter. And you need to be cautious on your spelling and everything else. Turn counter. And we're going to initialize our turn counter to, I'm going to just copy this box down here. We're going to initialize our turn counter to 0, okay, because he's not doing any turning. Okay. Abdullahs, if you could lower your hand, and same for Sassini. Thank you. We're going to set our turn counter to 0. And we also need to create our variable state. Okay. Okay. And so our state, we're going to set our state to, this is where we're going to use text. We could have used a number, but we're going to use text. We're going to start off going straight. Okay.
What does set state to mean again?
So our state is just telling, so we're going to apply our variable state. We've created a variable called state. We're going to set it to straight. We can set it to other variables as well. But the reason we have that is so that we can remember whether we're going straight or whether we're turning. Okay. Now Siri's tried to turn on. Right. Now this is a simplified model because we don't just have straight and turning. As I've pointed out here, we've got straight, turn right, turn left, and turn around. Okay, these are our other 3 states. Okay, so what we're going to simply do here is we're going to go to our code, and I want you guys to drag this out. So we're left with an empty shell of a program. Okay, then you're going to go to logic, and you're going to get your big system here, drag that in. And we're going to need to check 4 states. Okay, so click on that gear. If else, if else if else if. You want to drag in 2 more. Okay. Okay, just Fardin and Umar seems to have gone. Okay, so if our state, we're going to do our first check here. Okay, so, oh no, not that. Don't want to show you that. If our state, we're going to check if our state is going forward, and then we're going to check our other states. So back to our program. If, let's just copy that. And we're going to choose state. If state is equal to, and we're going to get rid of this block and copy that one and clip it in. If state is equal to straight, we're going to do this bit of code. We're going to run this function here. Otherwise, copy and paste because we're savvy. If state is equal to turn right. Okay, oh, sorry, turning right. If we are in the midst of turning right, we're going to execute this bit of code. Otherwise, if our state is now in the midst of turning left, we're going to execute this bit of code. And finally, does anyone know what the last one was?
It's when there's a dead end.
Dead end, and what do we do at a dead end?
Just gonna turn around.
We're going to turn around. Okay, so we're turning around. Okay. So these are our 4 states. These are 4 things that we can do. Okay. So we can pretty much take what we did before and throw that into our forward state. Okay, our forward state is going to check if we go for if there's something in front of us, we want to turn around, but now we can get rid of this, and we can get rid of all of this. Okay. Actually, no, didn't want to do that. That was stupid. Okay, now I've got to piece this together as how to explain it. So if there's something in front of us, we then want to perform some checks. So if something in front of us, perform... yeah, okay, so think about it like this, guys. If there's something in front of us, we could be in any one of these scenarios here on the top, right? There's something in front of us, but we should check our left and right as well to make sure that we don't need to turn left or right. Just because there's something in front of us doesn't mean we need to necessarily just turn around. Okay, so when there's something in front of us, if our front one is short, we're going to check our left and right. Okay, so we go back to our code. Can anyone guess what we're going to do here?
Check sensors.
Another if. Check
Yeah.
sensors.
So we're going to do another if, and I'm going to drag this if into here. It's a nested if. Okay, and here I'm going to check if my left is suddenly very big. So if my left is greater than, and let's choose a value of 15. If left is greater than 15, we're going to do something. Okay. Actually, let's start that already. If my left value, if front is less than 5, we're going to execute this. We're then going to check if the left is greater than 15. If the left is greater than 15, we're going to set state to turning left. Okay. Everyone happy with that? Can I get hands up if we're all happy with what I'm doing? If you're not happy, then please do let me know. Speak up. I'll answer any questions. I'll re-explain things. It's all fine. Okay. We can then copy pretty much this again. If the left one is not greater than 15, but the right one is greater than 15, we're going to set our state to turning anyone. First one to yell it out wins.
Right.
Right. Well done. No need to be scared. No need to be scared. Right. If in this case the front one is short and left and right aren't long, right? So back to our view. If we've got here and there's no left gap and there's no right gap, we need to then turn around. Okay. So what we're going to do? Anyone guess?
Turn around.
Turn around, bright eye. Every now and then I fall apart. And I need you now tonight. Right, so we're going to turning around state, okay? Make sure that if you're typing in this needs to be exactly the same written out as it is here, okay? Turning around here needs to be spelled the same. Turning left and turning left needs to be the same. Turning right and turning right needs to be the same. Okay, so we've now done a check to make sure that we've reached these scenarios. So if we've got something in front of us, we're going to check all of this. What about these? We could be going straight, but we need to check our sensors to make sure that there's nothing left or right of us. Okay, there's no open gaps. So what we're going to do is we're going to say if the front is greater than 5, if we're clear to go, I'm going to actually edit this to... Let's drag these out. Let's stop confusing ourselves. Let's just... Okay. We're going to do another check statement. We're going to say if the front is greater than, and so I'm going to get rid of... Really annoying that it does it this way.
Yeah, it's annoying that they're like parented.
Parented. How do I get rid of... Oh, yeah, just delete. Fair enough. You can get rid of that else on the bottom. Okay, so we just want if and then else if. Okay, and now if... do I want this? Yeah. If left is now greater than 15, so we're now looking for a gap. We're now checking this criteria here. We're now trying to see if left or right is greater. Okay, so we're going to go back to our code. If left is greater than 15, I'm just choosing these numbers arbitrarily. You can do whatever you want. Then we're going to do what? If we spotted a gap on our left, come on, people, talk to me.
Turn left.
Right, we're going to set our state to turning left. Okay. Yeah. And now I realize I've actually made a massive here.
Mhm.
Right, we're going to drag in another else if. And we're going to drag that else. Right, we're going to go back to what we had before. So now if our left, we're also going to then check if our left is like still a wall. We're going to check if the right is greater than 15. Okay. Is there a gap on our right here? Okay, we need to check this sensor here. Okay. If that sensor is triggered, what are we going to do? He wants to turn right, right? He wants to turn right. Okay. So what are we going to do in our code? We're going to say that if we see a gap on our right, if the right sensor suddenly picks up a huge number and the front sensor hasn't been triggered, then we're going to set our state to...
Is it turn right?
It is turning right. No?
Oh wait, my mic wasn't on. No, my mic wasn't on.
Yeah, I've heard that one before.
No.
Martin,
I was saying it and I was wondering why.
Martin, you can answer the next one. That's fine.
Ah.
Right, so if we've now done this, we've said if our front sensor is less than 5, we're going to check the left and front gap. Okay, so if... Maybe I should actually just whack this over here. Maybe that would just make things so much easier. I don't know if this is going to bug out or not. Yeah, of course.
Yeah.
Right. Great. Fantastic.
Oh, by the way, when you do that, you can just go on design, like when you split screen it.
I'm really worried because my code's just disappeared.
Yeah, I just watched that. I was like, where did
Yeah.
it go?
You go on, it disappears, but it goes to design. Oh wait, okay, that can go to the left.
Is everyone understanding kind of blocks so far while I'm waffling? Maybe Ali can just waffle and answer people's questions.
Anyone got any questions?
Come on, guys. We've been chatting for long enough that we should all feel friendly and close with each other.
Why didn't you save your work before?
Ooh.
I've got my other project.
Ooh.
Oh, cold.
Still doesn't help. I saved it and it still disappeared and I minimized.
Right, guys. So we were here. We've said if our front is less than 5, we're going to check our left and right. Otherwise, we're going to turn around. If our front is not, so else if our left sensor, so we're going to check our left here, is greater. Oh, these have to be greater than 15, don't they? Okay, so this is how easy it should be for all of you after this tutorial. Right, so Martine, I think we were here, and I was going to ask you. You best be ready for this one. We've checked if our front is less than 5, so if we've got something really close up, we're going to check our left and right sensors to make sure there's no escape. Otherwise, we're going to turn around. So that is essentially, let's just be savvy about this, save. So that is if we go here. We've checked if we've got a really short, we're going to check left and right. Now we're checking the short one hasn't been triggered. The front one hasn't been triggered, but we need to check our left and rights, okay? So we've got our left and rights there. If there's a left greater than 15, if there's a gap, we're going to turn left. If there's a right gap, we're going to turn right. Otherwise, what are we going to do?
Keep on going.
Keep on going. And how are we going to keep on going?
Was it not set state to straight?
It sets states to straight, yes, in a kind of way, but the state is already set to straight. Okay. This is quite a challenging question. If we're not going to make any turns, we're carrying on going straight. What did we do before to Rupert when he was going straight?
Had the same velocity for both of the wheels.
Had the same velocity both the wheels, but do you remember we had that control to make sure that he didn't veer too far left or right?
Now someone can help me.
Right. Okay. Does everyone remember that we put in a little bit of code at the very beginning when we were working with Rupert to make sure that he didn't go too close to the sides?
Was it a less than statement?
Yeah. So it was an if statement. It was this one here. It was to check the left, then the right, and then otherwise keep them the same. So we're going to say that if none of the sensors have been triggered, if Rupert's in a completely safe space, what we're going to do is we're going to do another if statement. We're going to check here. If Rupert's left sensor is less than, this time you need to be careful, is less than 5. We're going to just give that an arbitrary number. If it's less than 5, we're going to set his motors. Okay, we're going to set his left speed and set his right speed. If he's obviously too close to the left, we're going to change his left speed to a little bit more. So I'm going to give it 10, then his right, and 8. Okay. If that left sensor is fine, we're going to check. I'm going to add another else in. We're going to check his right side. Okay, we're going to make sure he's not too close to the right side. In doing that, we're going to copy and paste this over. The right sensor, we're going to check is less than 5. If it is, what are we going to do, guys?
Carry on going.
Well, yeah, but I mean, if he's too close to the right side, what are we going to do?
We're going to speed up the right.
We're going to speed up the right side. Okay. So we're just going to change those over. And if the left sensor isn't too close, the right sensor isn't too close, what are we going to do? Martine, you said this before.
Wait, keep on going straight.
Keep on going straight. Okay, lovely. Right, so we keep on going straight, which means what do we do to the both motor speeds?
Set them to the same velocity.
And to the same. Perfect. So they're both 10. Okay, so now we've done all of our checks. Now we need to say, otherwise, if he's going to change state, if he's turning, right? What did I say before we had here? We have to add our counter. Okay, our counter is how many times he's going to turn. Okay, so we've done all of this. We've done all of this. We now need to do this. Okay, so we're going to add our counter. We're going to add them here. Okay, so we've already created our variable turn counter. We're now going to set turn counter here. So whenever we're going to tell him to perform a turning left or right, we're going to set our turn counter, and I don't know, let's just set it to 30. Okay, he's going to do 30 iterations of that. Okay, and we're going to do the same thing to here as well. Okay, he's going to set his turn counter to 30. What are we going to have to do, though, if he wants to turn all the way around? If we've estimated that turning 30 times is going to turn him 90 degrees, how many times are we going to have to, how high are we going to have to set the turn counter to get him to turn 180?
60.
60.
Right, thank you, guys. Okay, so for turning around, we're going to set our turn counter to 60. Okay. On these turn counters, remember, any time that we ask him to turn around, we need to set our turn counter to a value. Okay. And that should be about it. There's only 5 points where we ask him to turn. Okay. All right. And those 5 points correlate to all 5 of the possible turning scenarios that we have. Okay. So now finally we can actually get on to what to do when he's turning. Okay. Let's say if the state is set to turning right, the first thing we have to do is check, but go back to our flow diagrams. Are we still turning? Okay. Do we still need to turn around? So we say logic. We're going to choose this one. If, can anyone tell me what we're going to do? If, yeah. If what? What are we going to check?
I'm asking what's the question? If it's
Sorry.
turned right.
Sorry, yeah. So if we're turning, if we're in the state of turning, the first thing we need to do is ask, is this turn counter greater than 0? Okay. So here we've got to our point where we're in the state of turning and we've got ourselves an if statement. What are we going to put here?
Turn counter equals
Yeah.
to 0.
If turn
Greater
counter
than 0.
greater than 0. Right, perfect. So we're going to copy this because this is our check. I'm going to change this to turn counter. If the turn counter is greater than, and we're going to get rid of this text bit here, copy one of these blocks, Copy and paste is literally your friends. Otherwise, you're up here going to math and picking a number and then having to drag that down. It's so boring. If turn counter is greater than 0, right? If the turn counter is greater than 0, what are we going to do, people?
Set state to straight.
No. Okay, so we're turning right. Okay, we're turning right, and we want to continue turning right. The turn counter still hasn't hit 0 yet. Sorry, so because we haven't finished turning. So what are we going to do?
Continue turning.
Continue turning. So what do we have to do to turn?
Add more to the counter.
The counter has to go to 60.
I'm loving this. Okay,
You
not the
need to
counter.
Change the speed of the
We have to
wheel.
change the speed of the wheels, guys. To turn, we have to change the speed of the wheels. So this is where we're actually telling him to turn. Okay, so we're going to get him to turn left speed and right speed. Okay, and if we want him to turn right, what do we have to do to these motors? Which one has to be higher?
The left one.
The left one, right? So I'm going to get him to turn on the spot, 10 and minus 10. Okay, I'm going to get him to turn on the spot when he reaches that point. And what do we have to do now? Because our turn counter is still at the same value. What do we have to do? So we've got here, okay,
Yeah.
if the state is turning, we've checked, is the counter greater than 0? We've told Rupert to now turn by setting the motor speeds. What are we going to do next?
So we will set the angle for it to turn.
We're going to do what?
Like set the angle we want it to turn at. The
So
angle.
The angle we're setting is based on the number of loops and how long he's turning. Okay, so he's gonna turn for a number of loops. But we've checked if we've checked the counter, we've done the turn. What are we gonna do next? Does anyone want to help Tarek out?
We want it to go forward.
All right, I'm gonna butt in here. We're going to want to decrement our counter, guys. It's the next block down.
Oh, okay.
Okay. We basically need to decrease our counter every loop. We decrease our counter by 1 until we've completed the turn, because we're checking, are we still turning? We know that we're still turning if the turn counter is greater than 0. Once we've done that, though, we have to reduce our turn counter by 1 loop, by 1 value, okay? So that eventually our turn counter does reach 0, and therefore we know that we finished the turn. Does that make sense?
Yeah.
Yeah, it does.
Yeah. Okay. So we're gonna go back over here, and we're going to choose the variable change turn counter. It's even given to us. Change turn counter by -1. Okay. Yeah. Otherwise, what are we going to do? If we've completed the turn counter and the turn counter is 0, what are we going to do here, people?
If it's back to 0, then do we go forward?
Then we go back, right? So we've completed the turn. So now we set our state to there. So we're going to set. Otherwise, set our state to straight. Okay. So can anyone guess what we're going to do for left and turning around?
You repeat the same thing.
We
Turn
repeat the same
counter.
thing. So we're going to take this and we put that in there. Now all we need to do though is, can anyone tell me the difference between turning left and turning right?
The right speed has to be more. The one
The
that's
right
positive.
speed has to be positive. Right, so we're going to change that one to negative, and we're going to change that one to positive. Well done, thank you. Anyone tell me what we're going to do for turning around?
So was it the what was it? The counter, and you had to set it to 60.
So we did that up here. We said that if we're turning around, the turn counter needs to be at 60, and then we're going to set the state to turning around. Now, when it's set to turning around, it's going to jump out of the loop, and it's going to say if the state is, and it's going to go all the way down here, and it's going to say if the state is now turning around. And what are we going to do in the turning around state? What are we going to put here? What piece of code, what blocks do we need to put in this bit?
That's the going straight bit. Go straight. If now it's turned around, go straight.
No, because now we are turning around. Does anyone else have an idea of what we're going to do here? Anyone want to butt in? Have I lost people completely with a state machine?
You just turn around normally, and then just carry on going forward. That's it.
So like,
You know, in our turnaround is again check our counter. It's exactly the same here.
let's check the counter bit.
We're going to check our counter is greater than 0. If it is greater than 0, that means we're still turning. That means we haven't completed the turn. So we're going to tell Rupert to keep turning. We're going to tell him to turn, and then we're going to decrement our counter by 1 value so that next time it goes through the loop, it'll decrement the counter again until finally we've completed that turn, and then this will not be true. The turn counter will be 0, not greater than, and we will set our state back to straight. Okay? So can anyone tell me, now that we've done it for the other 2, what are we going to put in here?
The same.
The same thing, right? It's exactly the same, right? We're going to check our turn counter is greater than 0. If it is, we're going to turn him, and we're going to decrement our turn counter. Otherwise, we're going to go straight. Okay, that's all we're going to do.
Why
anyone-
would you do the exact same thing again?
Right, because we're going to do it. Well, I mean, yeah, you could get rid of this and you could say turn. So you could, that's very clever. You could say we're going to turn right, but for 60 counts. Yeah?
Mm-hmm.
So there's another way you could do it. I was just laying this out in a structured way so that hopefully it would kind of make systematic sense. But yes, that would be the clever way of doing it. You just get rid of turning around. You'd have 3 functions and realize that turning around is just turning right twice.
I like that way better, but
Yeah.
okay, keep on going.
Okay. So this is technically our complete state machine done. Okay. So what we do in the first part is we check we're going straight. He's going to check if he goes straight, and he's going to do all this turning. Can anyone tell me what's going to happen when I press practice?
Is it going to go in the bits, the gaps?
It's going to try and go in the gaps, but because this is the actual world, it's not going to work. Okay. Your homework is to figure out why. Okay.
I see.
Tune these numbers, add in new variables, and figure out if you guys can get it to go between these gaps. Okay, so I'm going to show you what happens when we run it, and hopefully we shouldn't hit too many snags. He's going to go down. Everything's clear. He sees the right. Oh, he's completely missed it.
He won't ever find that. I'll tell you why.
Okay, hold on. I've experienced this problem before. So here we need to check our state machine. So he's checking it straight. The straight was fine. Front was less than 5. That's fine. He was checking left. He should have seen this gap, right? So he should have seen this here. If right is greater than 15, he should have seen this, and he should have set the counter to turn right. Okay. He was clearly doing all of this. That's fine. Turning right. And then the turn counter should have been greater than 0. Left speed to 10, right speed to -10. Is that going to turn right? Yes. And then turn counter by -1, set to straight. Anyone tell me what's wrong with here?
Also, you know those, out of interest, you know that right block that's just chilling on its own?
Oh yeah, these don't do anything, but we
It
just go
still
with it.
continues it. No, you can keep the text, but the right blocks, it still counts it as a thing, just in case you've got.
What right block, sorry?
No, you've already. Go to the top quickly.
This top or this top?
Oh, right at the top where you set things.
I'm just going to save that. Oh, right. Oh, sorry, the top of the actual
Right
script.
at the top. You see the turn counter is set at 0.
Yeah.
And you know how ifs are if learn, you know it's like if left at a set. Okay, no, ignore me. We put turn counters to ignore.
Yeah. Okay.
Ignore me.
Anyone tell me what's going on here?
Out of interest, Ben,
Yeah.
is the purple block a loop?
The purple block, yeah, this big purple block is a massive loop.
Okay, I was just.
So we're running through this whole thing.
And it does repeat itself once it gets to the end, right?
Yeah. If
Okay.
the front is greater than 5, we're going to check our left and we're going to check our right. I'll run it again. Else if that. So you should have picked up that right corner. where the right is greater than, set the turn counter to 30 and set the state to turning right. And then the state is equal to turning right. We should check all of this off. Okay. Anyway, I'm going to show you my other code and show you what this looks like with a little bit of editing.
Ooh.
Okay, so here I've added some new counters and stuff. And here you can see that we've got the exact same thing. If he's going straight, he's going to set it straight. If the front is less than 5, he's going to check. And then he's going to check right, and he's going to check left. And then if the front one was fine, he's going to check right, and then he's going to check left, and then he's going to carry on. And this one you can see when we practice it. He hits the wall for some reason when he starts, and then he just carries on going. I've never understood why he does that.
That's because it's me this year.
And so there we've got him going through the gap. Okay. And he's doing all his little turns. All right. So what I want you guys to do is tackle this during the week, and then probably next Thursday when we do our session, we'll see what you guys have managed to pick up on that previous code that I showed you, why it didn't work, and how you get it to run like this. Okay. And then obviously you guys bugged out at some points. Okay, and then we'll focus on actually refining this in the next week. And then what we'll do is some 3D design, 3D printing, and some other stuff. But we've been on here for far too long now. So we're going to go. All right, so have a crack at this using what you've learned, adding in some new counters and stuff. If anyone wants to ask me during the week what these are for, then I'm happy to explain, but I want you guys to have a crack at it first. Okay?
Yeah.
Look at him get stuck over here, silly Rupert. All right, so have a crack, see what you guys can get up to, figure out what was wrong with that initial state machine, what needs to be changed. Okay?
Yeah.
See you.
Right. Thank you guys. Cheers. See you next week.
Bye then.
Okay, bye. Good night.
You too.